I'm Nicole Wodislawski from the International Copper Association. My colleague, Malcolm Burwell, continues his interview with Jack Lifton, founder of Technology Metals Research.
Let's talk a little bit about the supply side issues that you alluded to. You know, we've seen this hiccup, as you described, because of the one-off, or perhaps it's not one-off, activity as China gets its environmental aspects of its rare earth supply chain under control. Do we think that supplies will always be limited for some fundamental access and cost of access reason, or is this just a hiccup in the limited supply problem?
No, the problem is this. The rare earths are not one thing. The rare earths, in fact, are two significantly different groups. One is the term in, the common usage is light rare earths and heavy rare earths. That has nothing to do with their density or their specific gravity. That has to do with their atomic number, which is, of course, even more confusing to the average person. But let's say that the rare earths are a series of 15 elements, beginning with element number 57 and ending with 71, including both ends. That's why it's 15. So 57 through 61 or 2 are called the light rare earths. And these are quite common. There's huge deposits of them. They're produced in China they are produced entirely in China, with a small amount today produced in California, a little tiny bit in India. And the reason that they're entirely produced in China is because the Chinese offer the lowest price. So the largest Chinese mining region, Inner Mongolia, produces light rare earths 50,000 tons a year, which is probably half the world's production of all rare earths, just the one region. And nobody can compete with them on price because it's a tiny part of a huge, China's probably the world's largest iron mining complex. And so the rare earth miners there have the advantage that infrastructure is a non-issue. They want electricity, they plug into the wall. If they want water, they turn on the tap. If they want workers, they pick up the phone. And if they want factory equipment, they pick up the phone. This is an enormous mining complex area. Inner Mongolia is a province, a state of China. Now, the problem is the heavy rare earths. The one that some people have heard of is europium, which is responsible for the modern color television display because it's a pure red color when it's made into a phosphor. And this is produced today in China. And then as we go up the ladder of higher atomic numbers, we get to terbium, which is critical for non-incandescent lighting, meaning that when a country throws out Edison-type light bulbs and brings in, Thomas Edison invented the fluorescent light too, they bring in fluorescent lights, they need terbium. As they do on cars for LEDs, they need terbium. It allows you to have a nice bright white light. And the next element is even more critical, dysprosium. Dysprosium is used in conjunction with the light rare earth neodymium to make magnets which will work under the hood of a car, which for the reason that you can heat them up and cool them down and heat them up and cool them down, and they maintain their magnetic properties. Iron magnets lose their magnetic properties permanently when you do that. Rare earth permanent magnets begin to lose their properties, and over time the properties are gone. If with dysprosium added, they maintain those properties. These are really important. It's a really important metal, dysprosium. Here's the problem. It's only produced in China today, and it only ever has been produced in China, and it's done by a complicated, long duration in time, very dirty process, which the Chinese are in the process of trying to bring under control. They'd like to stop it, but they can't because there is dysprosium for rare earth permanent magnets. This is important to China as it is to anybody else, to the rest of us. So we have the single source, China, for these heavy rare earths. No other place has ever produced them. And they're produced in a dirty way, and they're already in short supply. We're already short them in the world. So what this means is that light rare earths, you can produce them in California, you can produce them in South Africa, Australia, no problem. Prices on those will decline back to the levels they had before, maybe a little higher. But the heavy rare earths are going up in price and maintaining that price growth because supply is not keeping up with demand. So the really critical issue in the rare earths is the heavy rare earths, and for the automotive industry, the single problem is dysprosium. In China, they mine dysprosium from clays. They literally wash the material out of clay. It's very low percentage in the clay, and they use enormous quantities they literally flood mountains. That's the problem. They flood mountains with reactive chemicals, and they channel the material to pits lined with plastic, and they let that dry. That's the basic raw material, then refined. Well, the problem with that is, of course, when you flood the top of a mountain, you can't exactly determine where the stuff's going to go. So a huge amount of chemical material seeps into the ground, the rivers, the local. So some of these places look like the back of the moon. And a lot of illegal work like this was done. The legal work wasn't so helpful either. It's a big mess, but there's been no hard rock deposit of heavy rare earths so far developed. We have in the world today, in Canada, 2 or 3, in the United States, 2, in South Africa, 2, in Australia, 2 or 3 hard rock deposits that could produce dysprosium, but any one of them will be very expensive to develop and will take time. So in the near term, the next 3 to 4 years, there's going to be a shortage of dysprosium. So the price, not only is the price going to go up, you may not be able to get it. And as all of us on this call who have been auto suppliers know, if you tell the purchasing person, I can't get the material, they simply say, thank you, and call an alternate supplier. The alternate supplier can't get the material, then they call everybody in for a conference and they talk about it. And if you still can't get it, they start substituting. Okay, one thing is, unlike governments, industry cannot wait for things to happen. It has to make things happen. So this heavy rare earth crisis is on us right now. It is being masked by the nonsense that, it doesn't really matter because, they only sold 6,000 electric cars in the last 3 months in the world out of 10 million sold, or 15 million, so it's trivial. Well, that's not the point. Every car has this material somewhere in an under-the-hood application. And so my opinion is this. I think the big fear is in the marketing departments of the American, Japanese, Korean companies and European. And they're thinking, now what's going to happen is this. There'll be some car produced, and the Chinese will say, this car contains rare earth permanent magnets in all these applications and everything, and that unlike the cars made by those formerly state-of-the-art companies like Daimler and General Motors and Nissan, and all those people that used to make high-tech. This is the fear, that there'll be some kind of advertising like that. So right now, the rare earth industry does not understand that the automotive industry is not static. The rare earth industry has a huge problem of cost. You have to, number one, defeat the Chinese in cost. That's a real problem. And 2, you have to develop rare earth deposits for heavy rare earths that have never been put into production before by people who have never done that particular chemistry or metallurgy before. So you go, again, as the listeners know, when you go into automotive and say, I never did this before, but I'd like to give it a try. And they say, shall we base our 2016 production on your giving it a try then? Because usually they're looking at their watch and wondering where the next supplier might come in. So it's a huge problem right now in automotive, and everybody's running around pretending it doesn't exist on the outside. On the inside, I can tell you that the car companies are working with it, and the rare earth producers or wannabe producers don't seem to understand that there are substitutes, they do work, they're economical, might add a little weight, might be a little bit less efficient. Maybe they don't, maybe they're more efficient. But the automotive industry is looking at this, and the rare earth industry is not. So I don't know what's going to happen, but I do know there will be competitive cars made in the U.S., Europe, and Japan in 2015. Whether or not they'll have rare earth components, I couldn't tell you.
This concludes part 2 of Malcolm Burwell's interview with Jack Lifton. The discussion continues on part 3.